In the last video, I talked about how to find the least common multiple, creating prime factor trees, and then by pulling out the factors one at a time with these trees. And then at the very end, I showed you a fast method, a shortcut called the chain rule, where you could hop across to different factors and figure out what the least common multiple was that way. But I'm going to show you another way now that's really the fastest method. And the reason I showed you in the last video the factor trees is because I want you to understand how to create a prime factor tree and then how you pull these factors out, the factors that they have in common out. But really I'm going to show you a faster method now, and this is pretty simple to find the least common multiple. So we know that, for example, if I had the number 10 here, if I had the number 20 here, and I had the number 40 here, we know for a fact that using the chain rule that I just talked about, that if I can I can basically hop from factor to factor. I can go from 10 to 20 here, right? And 10 times 2 gives me 20, right? And then if I could hop from 20 to 40 here, right, using my chain rule, then I know that right away that the least common multiple is going to be 40 here. But there's actually another way to do this, and we're still going to use factor trees, but I'm going to show you it's a little bit quicker. And basically what we're going to do is we're going to write out the factors of all of these, just like we did before with the prime factor tree. So I'm going to start here. We have 2 and 5 on 10. Here on 20 I have 2 and 10. I have 2 and 5. And then here on 40 I have 2 and 20. I have 2 and 10, and then I have 2 and 5. So we're still doing the prime factor trees here, but we're going to take a little bit of a different approach. It's going to be a little bit faster. Here are my prime factors here. Here are my prime factors here. Here are my prime factors here. So what I'm going to do at the bottom is I'm just going to write out the factors, and I'm going to combine the bases and write them as an exponent. So if we look at 10, we know that this is just 2 to the 1 times 5 to the 1. And if I look at 20, I'm going to say that's 2 squared times 5 to the 1. And again, we're going in order, right? The smallest to the largest. And then here on 40, I'm going to have 2 to the 3rd times 5 to the 1. And now this new way to find the least common multiple, the fastest way, what we're going to do is we're simply going to look at each base. We're going to take the highest power. So this is 2 to the 3rd. I'm going to extend the page down here. This is 2 to the 3rd is the highest power for 2, right? So 2 to the 1, 2 to the 2nd, 2 to the 3rd. 2 to the 3rd is the highest power for 2. So I'm going to write down here 2 to the 3rd, like this. Okay, cross out the 2's. And then the highest power of 5 is just 5 to the 1, like that. And now you have your least common multiple. So that's a little bit of it's a faster method, right? And again, these are all valid methods. I'm just showing you now at the end here an even quicker method. So what is that? 2 to the 3rd times 5, that's just 8 times 5, that's just 40. So no matter how we do it, if we do it using the chain rule, if we do it using the traditional factor trees, or if I just pull the highest power of the exponent, we're able to find the least common multiple. So this is definitely the fast method here. But the other method that I taught in the first video is important because you need to understand how to pull the common factors out and just where does that concept come from of the least common multiple that they have in common. So let me look at another example here, and really this method of using the highest exponents of each factor come in very handy when we're talking about dealing with variables. So for example, if I took x to the 1 times y to the 1, and then I took x squared y to the 1, x y to the 4th, and I took, let's just say I have x to the 2nd power, and then I have y to the 7th power here, right? Now, if I want to find the least common multiple, if I'm assuming that these are all, let's say these are all just prime factors here, now I can basically just look for the highest power of x in this case. So if I looked in this case, we looked at this is x to the 1, x squared, x to the 1, x squared here. So my highest power of x is simply just x squared here, right? And what is my highest power of y? we have y to the 1, y to the 1, y to the 4, y to the 7. So my highest power of y is just y to the 7. So that's my least common multiple. So now it's a little bit easier, especially when we're dealing with these variables here, especially when we're dealing with the variables. It makes things a lot simpler to find the least common multiple of these variables. Now I'm going to show you the traditional way just to prove to you that this is still true, what we're doing. But that's the least common multiple. I'm going to write it over here just so we can remember it. Right up here. Okay, so let's just go ahead and find it the traditional way. I'm just going to show you that it works either way. Okay, so if I have x and y, if I have x and xy, and then I have x and y, here I have x and y to the 4th, I have y to the 3rd, I have y and y squared, I have y and y. And this one's going to be really long, right? Well, we'll just get started over here. I have x and x, y to the 7th. I have x and y to the 7th. Let me just zoom down here. This is going to be one of those long problems again. I have y and y to the 6th. I have y and y to the 5th. I have y and y to the 4th. Wow, still going. I have y and y to the 3rd. I have y and y squared. And I have y and y. So again, I'm doing this just to show you the long way, and you know that still works. And then I'm going to show you that we're going to get the same answer as this quick method I taught you by just taking the highest power of each one. But let's just go ahead and prove it here. Let's just prove this to you. So here are my prime factors here, x and y. My prime factors here are x, and y. My prime factors here are x, y, y, and y. And if we go down here, I should have 2 x's and I should have 7 y's. So let me just scroll down here. So here are my first x, my second x, first y, second y, third y, fourth y, fifth y, 6y, 7y. Wow. Okay, that took a long time. So let's start pulling these factors out. Okay, so the first thing I'm going to look for an x in common here. So here's my first x. I'm going to choose a different color here. My x in common here, my x in common here, my x is in common here, and my x is in common here. I'm going to pull that out once. I'm going to write it here like this, x with a circle. Cross it out here. I'm going to look for another x that's in common. I have an x here, and I have an x here that's in common, right? Pull that out. Let's make that a different shape, actually. Let's make that like a box, just so you can see that it's something different. It's not a circle. Okay, so I have my x here, and there's my box, just to show that it was a different, came from a different common factor, right? Because they had a common multiple there. And let's look for a y. Well, here's a y. Here's one here. Here's one here. Here's one here. And here's one here. So that comes out once. Here's my y here. Put a circle around it. Let's cross that out. Let's cross that out. Let's cross that out. Let's cross that out. Let me look for another common y here. Here's one here. So let's put a little box around that. Here's a common y here. Here's a common y here. So I put a y here, put a box like this. Take it out, take it out. Look for another common y. Let's do another shape. We'll do a triangle here. I'll do a triangle here. Here's my other y, triangle. Notice this takes a lot longer, right, to do it this way. But we are still pulling out the common factors, so you know it is still a valid method to do it. Here's another one here. So running out of shapes here. What's another shape I can use? I don't know. Let me just I'll just go back to the circle again. Circle here, right? So here's another one from that one. Here's a circle. Okay, and what am I left with here? Are there any more y's in common? No, and I have 3 y's here, so I have y, y, and y. So let's start combining our terms. How many x's do I have here? I have 1, 2, so this is x squared here. And how many y's do I have? 1, 2, 3, 4, 5, 6, 7. X squared y to the 7. And guess what? That's the same exact answer that we would have gotten if I just pulled out the highest x factor and the highest y factor up here. You can see that it's the same answer both ways, and it was a lot quicker just to take the highest power of x and the highest power of y and make that my least common multiple. They're both the same thing. Again, they both work. They're both correct. It's not wrong. They're both least common multiples. Just different ways to do it. And you know, it's important to understand where the factor trees come from and how to make a factor tree. But as you get more advanced in your calculations, you're just going to be able to look at the highest factor of each one and make that the least common multiple going forward. Okay, so hopefully you've seen a few tools here. We've seen the factor trees. We've seen the chain method. I can hop along here. So if I knew I could hop along, I knew that was my least common multiple. Or I can just write out the factors, the prime factors, and for each base, I just take the highest exponent and write them out, and that's my least common multiple. All right, I'm Shane Smolien. Thanks for watching, and I'll talk to you soon.